All right, this is a small piece of information just to complete what we've been doing. I will not be testing the methods students on this, but I do want them to be exposed to it. I do want them to understand. So I'd like you to finish watching the video, but don't worry if it's not perfectly clear. So what we're going to be talking about is what happens to our mean and our variation and standard deviation if we alter the data in some way. So say we collect a whole lot of data about heights. What if I change my units from centimeters to meters? Or what if I got some scores in a game and we add something to everything? So I'm just going to, this equation looks complicated. What it's saying is the expected when you got a times x, this would be like changing the units. So if I'm going from meters to centimeters, that would be 100. Each of my values is 100 bigger than it originally was. Or the plus b is adding on to a score. So everyone gets 50 points to start with plus whatever you scored or something like that. And what you do is actually fairly logical. Well, if I was just changing my units, the average of the height shouldn't change except for I have to change my units as well. So that's what that A is. That would be 100. 100 times the previous average in meters would give you the average in centimeters. And the plus B is just saying we add on the score. So if we're giving everyone 50 points, then the expected is going to be 50 points higher. That kind of logic when we look at it like that, but it is a bit confusing. Now, what happens to our variation? Well, this plus b does nothing to how spread out our data is, so it doesn't even appear here. So the variation is not changed by adding something to all the scores, but it is changed if you multiply the scores. So if we had that change of units again, or something similar, multiplying, everyone doubles their score, whatever it is, then the variance actually takes that amount and squares it. And that's because our standard deviation is just that amount times standard deviation. Because the variance is the square of the standard deviation, or the standard deviation is the square root of the variance, whichever way around. Standard deviation is what you expect. It's just a times the standard deviation, so it multiplies by that change, whereas the variance you have to do a square. I hope that explains it. I'm not going to do a bunch of worked examples. We might do a couple in class, but it's not too bad, except the formulas look very messy.